Hello again, grade 7s. In today's lesson, in the circles unit of study, we're going to look at using some mathematical equations to calculate the area of a circle. And the learning outcome is just that, to develop and apply a formula for determining the area of circles. Maybe just before we get into this, we'll just quickly do a review of all the different quantities we've talked about so far in relation to a circle. So I'm going to pull out a green felt here. Okay, so let's say this is the center of the circle. And now I'm going to label the center of the circle as being M. If we draw a line from the center of the circle M to the outside, that's what we call the radius R. If we draw a line that cuts the circle directly in half, I'll do this as best as I can, that's what we call the diameter. The diameter is a line that goes from one side of the circle to the other, but it must pass through the middle of the circle or the circle center. Then the other quantity we talked about in the last lesson is if you took, for example, a string and you wrap it around the outer perimeter of the circle one time, that's what we call the circumference. The area is just going to be the region that is going to be enclosed within your circle. So I'm just going to shade in all of this. This would represent the circle's area, how much space is being occupied within the circle. To calculate the area of a circle, we have two different equations. One equation we're going to use if we're given the radius of a circle, and the other one's going to be useful if you know the diameter. This one's the more common one that people use to calculate the area of a circle. So what we have is the area of a circle is equal to pi times r squared. I do just want to quickly talk about this exponent here. So we don't talk about exponents a whole lot in grade 7, but just to kind of give you a breakdown of how they work. So for example, let's say I had a number that was like 3, and then I had a 4 up here. So this number at the very top is what I call an exponent. And this bottom number right here is what we call the base of the exponent. The way we evaluate this, so if I wanted to expand, and usually we refer to it as we say 3 to the power of 4. The way you write this is the exponent tells you how many times to multiply the base by itself. So what I would do here is 3 to the power of 4 would be 3 times 3 times 3 times 3. So I've multiplied the base by itself 4 times. If I had, for example, 3 to the power of 2, and oftentimes we just refer to that as being 3 squared, that means multiply the base by itself twice. So that would just be 3 times 3. The exponent rules still work even when you have a letter. So what would r squared be equal to? Well, it means take r and multiply by itself twice. Therefore, the area would just be pi times r times r. Case 2, if we're given the diameter of a circle, well, one thing we could do is you're given the diameter of a circle, perhaps it's easier just to take the diameter and turn it into the radius. And the way we could do that is just use the equation r is equal to d divided by 2. But then you'd have to do 2 separate calculations. So I'm going to show you the equation we can use to calculate the area of a circle from the diameter. It's a little bit more complicated. So this equation looks like the area is equal to pi times the diameter squared divided by 4. Again, a fraction means division. We'll expand this a little bit to expand the exponent. And when I do that, it would be area is equal to pi times d times d. Again, you're multiplying d by itself twice because of the exponent 2. And then I divide that by 4. Okay, let's do some calculations for this. I'm going to change my pen color. Example 1, we're given the radius of a circle, and we want to calculate the area to the nearest tenth. Okay, so we'll again use our three-step procedure for showing work. So in step one, you write down your equation. The equation I want to use here is the one that has r in it. So that is the one that tells me the area is equal to pi times r squared. We can expand this. We can say area is equal to pi times r times r. And then we can just plug the numbers in. So step one would be to write down the equation. If you want to, you could jump straight to the second one here, or you could just leave the first one without showing the expansion. And then this would be equal to, well, do a substitution. Pi is 3.14, multiply by r, which is 8 centimeters, multiply by another 8 centimeters. And let's calculate this. So I'll plug it into my calculator. So I've got 3.14 times 8 times 8. And then I get a number that would be 200.96. Now the units, you gotta be careful of this for area. If you look in the actual calculation, what I'm doing is for units, I'm multiplying centimeters times centimeters. So I could kind of work backwards now and write that as a base with an exponent. Centimeters times centimeters would be centimeters squared, or centimeters to the power of 2. Therefore, you'd have area as 200.96 centimeters squared. We're going to round to the nearest tenth of a decimal place. So let's look at what's happening in the hundredths position. Okay, so the hundredths position is a digit that is 5 through 9. So it means we're going to have to round up. Now, this is a little bit tricky because the tenths position is already at a 9. So what would that 9 round up to? Well, I guess the 9 would round up to a 10, but you have to show the 10 in being in this position just to the left of the decimal place. So this would actually round to 201.0 square centimeters. It's a little bit tricky when you have to round a 9 up. And again, essentially you're just rounding it to a 10, but you have to show the digit 1 for the 10 just to the left of the decimal place. Okay, second one, we have r is 14.8 meters. So I can go area is equal to pi times r squared. Again, that's the equation we want to use if we know what the radius is. So this would be equal to pi times r times r. Let's plug these numbers in now. So we'd have area is equal to pi is 3.14 times 14.8 meters times 14.8 meters. And then let's see what this is unrounded. So if I plug that into my calculator, 3.14 times 14.8 times 14.8 would be equal to 687.7856, and meters times meters would give me units of meters squared. In fact, any area calculation is going to have square units as the units. Okay, how do we round this? Let's look at the hundredths position. So that's an 8, which is going to tell me I need to round the tenths position up by 1. So this would then be area is equal to 687.8 meters squared. Example 2. Now we're given the diameter, and we're going to calculate the area. So one thing, again, you could do is if you just want to use the area's pi r squared equation, you could just take the diameter and divide it by 2 to get the radius. That is possible. However, I'm just going to show the work using the other equation. So the other equation is the area is equal to pi times d squared divided by 4. If we expand this, this would be 3.14. Oh, not quite yet. We need to, jumping ahead, we need to write the expanded equation down first, and then we'll plug the numbers in afterwards. Okay, so we'd have pi times d squared, so we write it twice, divided by 4. So this would be equal to, now let's do the substitution. So pi, we're going to use 3.14 times the diameter, which is 20 centimeters, times 20 centimeters. And then we have to divide that by 4 at the end. And then now we get an area, and let's get an unrounded answer first. So we'd have 3.14 times 20 divided by 4. And actually, it turns out this gives me a really nice number. This gives me a whole number. So it gives me 314 square centimeters right on the dot. Because it's a whole number, there's really no reason to express it to the nearest tenth. Okay, and then the last one, we have d is 6.8 meters. So I'd have my area is equal to pi times d squared over 4. Again, I use this equation because I'm given the diameter. And that would be equal to pi times d divided by 4. Now let's plug the numbers in. So pi is 3.14. D is 6.8 meters. Multiply by another d, 6.8 meters. Divide this by 4. Suspect this time around we're going to get a lot of decimal places. So we have 3.14 times 6.8 times 6.8 divided by 4. And when I do this, I get 36.2984 meters times meters. You give me square meters. To round this, look at the hundreds position. That's a 9. So that's going to make that 2 round up to a 3. So then we'd have area is equal to 36.3 meters squared. Okay, and that's it. So you can complete MathLink 7, page 285, numbers 4 through 11. And they're just going to be questions, again, where you're going to apply a mathematical equation to calculate, although this time you're going to calculate area instead of circumference. Also, for the problems where it tells you to estimate and then calculate, just ignore it. The calculation is totally fine. The estimation would be if you rounded pi to 3. There's no reason to do 2 separate calculations for this. And I will talk to you in the next lesson.